It's 3 o'clock, so let's get started. So everyone had fun with assignment 1? Everyone got it all done? Pretty much everyone did very, very well on it, so I'm very pleased with that. I've seen some really, really creative solutions with the minimization part. So, and actually, a really funny thing, every single person picked the passwords option. No one did the frequencies one, so I thought that was funny. But I included the solution for that one also. So, any questions about assignment 1, how that went? Everyone's, except for a few of you, for some reasons, your grades are up with the explanation. So if you have any questions about your grade, send an email to me. All right, so let's just go over the solution. So I have both of the first part solutions here. So pretty much everyone hit these fine. So what I do is I have a list of special characters, and then what I do is I do basically shorthand in Python. What you do is this is a generator expression. So what I'm doing is saying that I set low to be 1, the variable low to be 1, if the sum of the number of characters that are lowercase is at least 1. So it's just like an indicator. It's 1 if there is a lowercase character, 0 if it's not. High is the same thing. Num is if any of the characters in the password are a digit, so from 0 to 9. That's just calling the character .isDigit. And then special is the same thing. It's just counting the number of characters in the line in the password if it's in this string. And that's also an indicator. So if the number is at least 3, then we print it. And I also check that the length of the password is at least 8, and that since set takes away all duplicate characters, so it just removes every single character, and then I just call len on that. So that'll take care of the part about checking if there are 8 or more unique characters. So that if statement will do at least 8 characters, 8 unique characters, and I do the sum for at least 3 of the 4 requirements. Okay, pretty straightforward. So any questions about, yeah?
Couldn't you just remove the first line of line is greater than 8? The second one accomplishes the same thing?
Yes, but I wanted to make it more explicit. Yeah, so technically, yes, I could. You had a question?
I was going to ask a similar one, but also there's a new line character at the end of each line.
Yeah.
How does that take into account that?
Oh, so what I did here is I call strip. So what strip does is it removes spaces and new lines off both sides. So what I could actually do is I just call rstrip, which means right strip. So what that does, it does that same thing, but only on the right side of the right side of the word. Yeah. So that'll take care of the new line. But yeah. So yeah.
So for the punctuations thing, I imported a string. This is string dot punctuation. I'm guessing that doesn't have space on it, right? Because I was always on like point something. I'm fairly certain that I think your special has space.
Yeah.
Character, I'm fairly certain that one doesn't.
So
I was wondering that.
So what's the surefire way to check whether what a functionality does in Python? Well, I can print it, or what can I do to figure out what something does? Well, I can do that, but what's the surefire way to get exactly? I know exactly what it does. Go to the documentation, exactly. So Python string punctuation. So let's go here, go to the Python 3. So punctuation, string of ASCII characters, which are considered punctuation characters in the C locale. That doesn't seem very helpful. So I guess the documentation it should always be helpful, but it's not here. So what we can do is we can fire up the interpreter, import string, which is the module for this, string.punctuation. Okay, so Actually, this is where I got string the punctuation characters. So,
Oh, you just copied them.
oh, what's that?
You just copied them.
Yeah, but I also added a space character because you could have a space in there. If you make a valid case, I could reconsider whether a space is considered a special character because I don't think I made that clear in the assignment. So if you want to make that case, that's fine. But everyone did well enough, so I don't think that's necessary. But
Mine was just more curiosity than anything else.
oh, okay, yeah, that's fine. Any other questions about that? Okay, so letter frequencies. Well, no one did it, but the way it works is you read a line, and since I'm only caring about whether the lowercase version of each character in the string, so I basically make all capital letters lowercase. Then I iterate through the string, and then I check. I basically just do the counter when we covered counter, which is one of the classes in the. I should know this. In the collections module, yeah. So it's one of the classes in the collections module which counts the unique characters in the string. So what I do is I make a dictionary and then I just iterate through it and count all the alpha characters. So all the characters between lowercase a and lowercase z. So then what I do is for every single entry in this dictionary, which may or may not have all 26 characters, I basically normalize by how many alpha characters there are because I don't want to consider all the other characters like periods and spaces and all the special characters. So what I do here is I just divide by the length of the number of alpha characters in the string, and then I multiply by 100 to get it between 0 and 100%. Because dividing by a length will put it between 0 and 1, then I just normalize it to 0 through 100. All right, and then it may or may not have the characters A through Z, so what I do is I look through ASCII letters, but that gives me lowercase a to lowercase z and capital A to capital Z. And then, so if I just call L dot lower, what that does will just give me, and then call set on it, will just give me the lowercase letters. And then for every single character in the sorted version of this, because set is unordered, so it may give it to me in the wrong order, because I want to print A first, B second, C third. So what I do is, if the character that I'm currently looking at is in the dictionary, then I just print whatever the percent was associated with it, formatted correctly to have the percent character at the end of it, and format it to 3 decimal places. So that's what that 0.3f is. And then otherwise, if I don't see the character in my counter dictionary, then I must have never seen it in the string, so I must print 0% because it's not in the string. All right? It's pretty straightforward. So any questions on how that works? All right, so now the moment everyone's been waiting for. So for the minimization, everyone had very amazing solutions. Everyone had really great ideas. I don't think anyone did the same 2 ideas, so everyone did something different, which is pretty nice. So let's start at the top. So the original file, just as is, had 1976 bytes. So I was actually able to get it down to 241. That's my current best right now. If any of you beat it, please let me know so that I can see how I can do better than that. And I'll post the code of what it is on the site so that you can play around with it. So the first big one is removing all the comments. Everyone pretty much did that. Everyone removes comments, and you can also remove any blank lines between any 2 functions or two statements, because that counts as a character. We don't need it anyway. So what I do here is I just remove all comments and all spaces and all blank lines. So that's what that does. So now, not everyone did this. So one of the big things is when I gave you the file, all of the indents by themselves had 4 spaces. But in Python, it actually doesn't matter how many spaces you use for indents as long as you use an indent. So you can actually, instead of using 4 spaces considered as an indent, you can use 1 space instead. So what I did in the my solution was I looked everywhere where I saw 4 spaces and replaced it with 1 space, and it did that through the entire file. So that cut it down to 972. So now this is what it looks like. It's very hard to read now because of the indents, it's not quite good, but it still works exactly as before. And so that's all I do here. So that's the entire file. Then most everyone saw this. You can reduce, it doesn't matter what the names of the variables are, you can just reduce it down to 1 character as necessary everywhere throughout the file. So that brought it down to 669. So like instead of saying, flag is equal to true, I just say L is equal to true. And then I just use the name for that, yeah. It's much easier to do that. All right, so most everyone saw this one. The function, which is now called E, but was originally called eliminate duplicates, most people saw, oh, that's just the set function in Python. So I can eliminate that entire function and just replace it with set. But the thing is, we need to return a list because the original functionality depended on that it was a list. Actually, it doesn't, but I just want to be sure that I have the same functionality. So I need to feed the result of calling set to list. So instead of having this function now, E of C, what now I have is calling set on the sorted version of what handle inputs gives me, and then feeding that to list. And then everything else works exactly the same. All right, so that was a reduction to 65 bytes, so 604 now. Then, oh, I forgot to update this. This should be 604. So I didn't want to make a separated subsection for each one of these, so I just grouped a whole bunch into one. One thing we can do is, for the function up here, when we do the primality test, what we're doing is, if L is true, then return true, otherwise return false. So what can I do instead? Get rid of all of it and then just return L, right? Because if L is true, I return what it was. Otherwise, I return what it was at that point. So I just return what it was. So at that point, I just return L instead of doing that if-else condition. We can actually remove L altogether by doing a generator expression, but I don't think I'd do that here. So right here in f of n, it turns out that we didn't need to use these 2 variables, so just remove them. We don't ever use them. In this main function, I can actually, since what I can do is I can call sorted on list and set. Like I could feed the result of set and list into sorted, and then just put that in where in the for loop itself. So I can just replace this S with sorted list of set of C. And so that saved a few. I told you last time, but I'm sure most of you figured this out. I don't care about running time. All I care about is saving bytes. So the optimization we talked about in class with respect to only going up to the square root of the number, we can just eliminate that optimization. And we can just replace this entire thing with n, right? Because for range, it goes up to the last number minus 1. So I need to test up to n minus 1 here, possibly. So I can just effectively remove all this with just with an n instead. But that also means I don't need this import for math because that's the only place I use math. So I can remove both of those. Anything else I can make? Since I removed math, I don't need to do this, but you can actually, instead of doing 2 imports on separate lines, you can do import math comma sys. So you can do a comma separated list of imports also. So that you can do that too. In this function f of n, I have 2 variables, but I could actually initialize both variables at the same time using unpacking. So here, instead of I equals 0 and u equals 2 on separate lines, what we can do is instead do I comma u is equal to 0 comma 2. So 0 will be initialized to I and 2 will be initialized to u. All right, so that's exactly this. Just another way to say bytes. It turns out for function arguments and spaces around operators, so like these +1s, we don't need these spaces. So everywhere I have those spaces, I can remove those, as well as like around function argument lists. So between S and C here, I can remove the space. So a whole bunch there, and that's it. So that'll take me down to 466. So this is the result of that. So I call. Actually, this is in the wrong order, but it's effectively this. It's the same number of bytes, by the way. Yeah, it doesn't matter. So another big one is removing the prime function altogether. So we can. Well, what does the prime function do? It says that if the number is prime, then every single divisor between 2 and n-1 cannot divide this number, right? So if I try to divide the number, what is the remainder? Well, it can't be 0, right? Because if it were 0, then it could divide in. So what we can do is every one of these checks will have to return true. But that's just what the all function does, right? So I can just do a generator expression and just say all I want to check every single divisor. So for every d in range 2 to n, I want the condition that n% is not equal to 0. Okay? So that'll save a whole lot of bytes. So instead of calling p of u here, which we'll call the prime function, I just say if all this expression, which will mean that it's prime. All right? You can actually do better here because what counts as true in Python means non-zero. So that basically means when we do our modulo d on our number n, we can just say n modulo d would correspond to true. So I don't need to do the check not equal to 0 here. So I can actually optimize this to be all of n% d for d in range 2 to n. And so that'll take me down to 391. And so another thing you can do is if you have one thing in, say, a for loop or an if statement, you can actually hoist that entire line into the if statement or the for loop. Okay? So any questions at this point? Yeah.
Could you explain that if all statement one more time?
Yeah, so what does the all function do? What it does is either given a list or a generator expression, so I have a generator expression here, it will return true if everything inside it returns true. Okay? So it just means if all of the things in here are true. So what this does is this will return either 0 or not 0, right? So if it returns 0, then it'll correspond to the number is not prime, right? So 0 in Python in most languages corresponds to false. It'll evaluate to false. So here, if there is any such d which divides evenly into it, it'll return false. So the all will return false. But if there isn't such a d, then every single element in there is true. So therefore, all will return true, which means that the number's prime anyway. Okay, so it's just a nice optimization that you can do. Cool. And this also uses a really neat solution for reducing this program size from one of the submissions. So I will thank that student in the solutions when I finish this up. But anyway, that's all I do there. So you can actually reduce the function handle input. So this is also from one of the solutions. So one of the student submissions. And what you can do there is you can hoist the try except statement into the main function. So there are so many things, so I didn't all cover it all at once, so you'll just have to read the solutions. But all I'm doing here is basically hoisting all of that work all into one method instead of having two methods for it. So that took me all the way down to 329. And so that is my current best right now for just doing this completely directly reducing bytes. So at this point, are there any questions before we get into the cool stuff? So if we want to get less than this, we'll have to be a little creative. So a few of you did this. So for those who did, what did you do?
So I remember one of the days I came here and asked you what PIP3 was.
Yeah.
And immediately after you explained what it was, I looked it up, like looked up what I needed, and right then, within 5 minutes, I went from 390 something to like, you know, it was like 200 something.
Right. So pip, for those of you who didn't do it for your solution, is basically the official way to install other modules that aren't part of the standard library. So just as an example, one of the prime functions is called primesive, just primesive. So if I wanted to install that library, I think I already have it installed, but what you would do is pip3, which corresponds to Python 3, pip3 install primesive. And so it'll go all the way. Since I already have it on my machine, it'll say requirement already satisfied. But if you don't have it, what it'll do is it'll go out to the central pip3 server. It'll download a copy to your machine and install it in the same place as your current installation. So what you could do now is you can import that as a module, right? So there are quite a few prime function modules available in pip, and primesive is one of them, but one with the shorter name is pyprimes. So a really nice method in pyprimes is called nth prime. So what you do is you feed an integer to it, it'll return you the nth prime, which is exactly what this program's doing in f of n. So effectively, I could remove f of n directly, just do an import of pyprimes, and then just call pyprimes.nth prime, which is exactly what I do here, which will bring me down to 264. So in this extremely long line, I print x corresponding to pyprimes.nth prime of x. Okay? It's exactly the same thing. So a crazy one that I didn't see anyone do, but one thing you can do is you can, since all variables are objects in Python, all functions are also objects. So technically, you could assign a function to a variable directly. So one function we're calling over and over again is print. We call it 3 times. So you can assign p to be print, and then just call p of whatever you want. And you can do that. And since I didn't want 2 initializations of variables on 2 lines, what I did is I did a comma with unpacking again. And it turns out if you do this with any other function in this program, it'll increase the number of bytes. So I don't think you can actually reduce this any further in terms of assigning a function to a variable. Yeah. What does the exit function do? Well, I want to do the exact same functionality. So what does exit 1 do, if anyone knows?
It's an error.
Yeah, it's an error exit. So what is...
Yeah, I made the mistake of taking out the, if it's less than 0 and combining it all into just saying error if it was less than 0.
Mm-hmm. I think it defaults to sys exit, but I'm not sure. So sys exit. So exit from Python. So sometimes the Python documentation is just terrible in telling you what you want to know, but it seems like it's the Unix error. Well, the Unix code for exit. So it's like the same thing as the C exit or whatever other language you want to use. But so what I think here you do need to, all you need to do is return some non-zero exit code. So any non-zero number will work here. So I don't think you can do this any better because I only have one call to exit here, whereas before I had multiple. Not here, but. For which one?
Don't you need the exit after value is less than or equal to 0? Otherwise, it'll, like if you have multiple inputs, it'll continue
when I did, well, I'm checking if all of these are at least 0, then I do the nth prime thing. Otherwise, then I just print. I don't do the for loop. Yeah, and you may think, well, why not you do an exit there? You only do it after you do the exception. Well, that's actually, if you look at what the original function did, it only printed to std error. It actually didn't do an exit. Oh, no. Huh. Actually, maybe it did. Huh. I'll need to relook at this. Yeah, I guess it should have done an exit one. Yeah, I'll look at this again. But the point is that you can assign a function to a variable and then use that variable over and over just as calling it. And then one of the last optimization I can make was, well, notice that there's only one function that I declared now. So, and the only place that I declare it is here. So what I do is I hoist everything inside M into the if statement below. So, and it turns out, since I should have done this earlier, but it doesn't matter what you feed to sorted. It doesn't have to be a list. So as before, it could have meant a difference whether it was a list or a set. But here, since I'm feeding it only to sorted, then I know for sure that it doesn't matter whether it's a list or a set. So I can remove the list call here. So instead of all I need to say now is sorted of set and then mapping the integers onto the list of strings. But yeah, there should be an exit 1 here. So this 241 it shouldn't be right, but otherwise that's the best I can do. I can't lower it anymore than this. So any questions about that? I hope that was fun to try to lower it as much as possible. Yeah.
Any chance I can reset it?
Well,
just removing those indentations.
That was a huge one.
Between the operators got me down to 378.
Yeah, just doing that was a huge help to some people. Yeah, some people. Yeah, it was subtle, but it really did help. So yeah, any other questions about this? All right. So last time I said that I didn't have the material ready for to start working on it yesterday. Well, I realized that I went back and looked at what the previous course did, and it turns out that we completed already 80 to 90% of what the previous course did. So technically, I could just run through the last bit of material and count some of the next 6 weeks of classes. Someone went, woo! Yeah. I'm sure that you guys wouldn't want that. You want to see what other cool things you can do. And plus, we have the project too. So I don't think I can do that. But what I think would be interesting would be to, because what most people have trouble with in upper level classes is, well, they understand the theory, but they don't know how to apply it to real world, well, quote unquote real world problems. Like given a problem statement, they don't know how to start working on it. So what I thought to do was, since you guys have Project Euler problems for your assignment 2, you have 4 of them to do, I thought let's just do some of the other ones that aren't on that list, just as for fun for our exercise. Okay? So the 2 I wanted to work on today were problem 2 and 9. So what problem 2 says is, you're given the Fibonacci sequence. So what is the Fibonacci sequence? It's just you initialize two numbers, 1 and 1. So you call it F1 for the first number, F2 for the second number, which is, they're both 1. And then every other term in the sequence will be the sum of the last two terms. So the third term will be 1 plus 1, so which will be 2. Then the fourth term will be the last two numbers, which is 1 and 2, so it'll be 3. Then 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, and so on. So what they did is they started off at 1 and 2, but it's exactly the same thing. So what they want you to do is we only want to consider the terms in the sequence that are even valued. So here 2 is even valued, 8 is even valued, 34, and so on. So what we want to do is find the sum of all the even valued terms that are less than 1 million. Okay, so I want to produce the sequence, find all the ones that are even, and then just add them all up. And then whatever that number is, I want to report that to Project Euler. Okay? Okay, so let's start working on that. So here is the problem statement. I should have this on multiple lines. First. Remember what I said about live coding demos? Never, ever do them. Okay. All right, so how would you attack this problem? Might want to make this a little bigger. Well, I got to start producing the Fibonacci sequence somehow, right? So how would we start doing that? Yeah.
I remember doing it recursively in 205
Well, it turns out the function runtime, let's just say that the function's runtime is t of n, and it's obviously, since we're doing a recursive call on n-1 and n-2, so it's the runtime of n-1 plus the runtime of n-2. And how much time do I need to combine these two numbers? To add these two numbers together? Constant time, yeah. Well, in a sense, constant time, yeah. So it turns out that if you, the master method, as we covered yesterday, as well as guessing, can't actually get this exactly, but to figure out what the runtime of this is, but it turns out that this is phi to the n about, or really O of f. So what do you think phi is here? It's actually, well, it's the golden ratio, it turns out. So this is about 1.61 to the n. So this is exponential time, so it'll be really slow to actually do it. You could do it this way, but it's really slow. So we'll need another way. So what's another way we can do this? How about just do it iteratively? So let's see. So what we can do is we could have, well, we're going to need two values to keep track of. One, which is the current Fibonacci number, and the one that's previous. And then update as needed. So we have, let's just call these names. So previous Fibonacci is 1, and my current Fibonacci is 1. So the previous Fibonacci will be the before number, and current will be the one I'm currently looking at. Okay? So to find the second one, it's just previous fib plus current fib. But let's see. Oh, it's 4 million, not 1 million. Never mind. So what I want to do is the current Fibonacci is the one I'm currently looking at, right? So I want to make sure that as long as current fib is less than 4 million, then I want to keep doing this loop, this iterative process. So while current fib is less than 4 million, So I could write it like 4,0,0,0,0,0,0, but I may miss a 0 here. So what's another way I can write 4 million? So how would I write that as an exponent? Times 10 to the 6. So times 10, how do I write to the here? Star, yeah. So that's another way to write 4 million. All right. So now I want to update my variables as needed, right? So how do I update my variables? Well, I want curfib to be curfib plus previous fib, right? Because lights went off again. Right, because I want it to the new current the new current Fibonacci number that I'm looking at will be the next one in the series. So that's really just the one I'm looking at plus the previous one, right? So that's exactly what we want. But if we do this, then we never update the previous one because it has to be the one right before. So what should previous fib be set to? Well, previous is where it was here, curve fib was right here. Curve fib moved forward, so where should previous fib move? Well, forward to what was right here before? The curve fib was. So I better do this assignment to previous fib right before I update curve fib. Because if I update curve fib first, then it's moved forward, but I don't know where to move previous fib to.
But then when you add pre-fib right there, you add curve fib plus curve fib. Could you do after the curve fib? Could you do?
Oh yeah, you're right. So we actually, it'll be much more difficult if we do it this way. So what I want to do is I want to update both variables at the same time using the old values. So the way to do that is doing this unpacking thing we've been talking about. So when we do unpacking, when using the values on the right-hand side, we're using the old versions of the values. Okay? So I want previous fib to be, so the first element over here should be curve fib, and the second one should be what curve fib will be. So the values on the right-hand side will be the old values, so curve fib is the old value, and also the previous fib is the old version of pre-fib. So when I make this assignment, prev fib will be updated with the old value of curve fib, and curve fib will be updated with the old value of curve fib plus the old value of prev fib. Okay, so that's exactly what I want. All right, so but we didn't actually do anything with respect to the question, right? So what we want to do is we want to add up all the even value terms. So what should I test as a number to be even? What thing should I test to be even?
Curve fib mod 2.
Yeah, so curve fib mod 2. So if curve fib mod 2 is equal to 0, then now I need some kind of sum variable to keep track of, right? So sum, I'll just call it s, is 0 initially. And then what should I do with s here once I test that curve fib is an even number?
If it is
Add it to s, yeah. So s plus equals curve fib. Okay. So now, what do I do after the loop now? Print the sum, yeah. Print s. Awesome. That was easy. So let's go to Python 3, Euler 2. All right. So that's my sum. And let's see, do I have an account? Of course it did. Does anyone have a login account? Okay. I'm sure this is correct because I've done it before. But if you want to test that value is correct, go ahead. But so, any questions about how we were able to do that?
Can you go back? What was the answer?
4613732. Yeah. So it's
all the even values.
yeah.
That's 40 million.
Of all the even values in this sequence. Yeah, and not all even values, period.
Yeah.
Yeah. Cool. So, we'll come back to a point I want to make, but let's go on to the next problem. So the next problem is this one. So a Pythagorean triplet is just a set of three numbers for which a squared plus b squared equals c squared. So we've seen this in trigonometry where we talk about right triangles, and you have one side is a squared. Oh, sorry, one side is a, one side is b, hypotenuse is c, and they're related by the sum of their squares. All right, so just an example, 3 squared plus 4 squared is 5 squared. So that's an example of a Pythagorean triple. So it turns out that there's exactly one Pythagorean triplet for which if you add not a squared, but a plus b plus c is equal to 1,000. So now I just need to figure out what that triplet is. Okay? So that's my goal. So how would you approach this? Well, how many integers could I possibly be searching here?
3 different integers.
Well, yeah, like what's my range space for each of the integers?
0 to 1,000.
Yeah, well, what about negative ones? Why is it not negative here? It actually says in the description. Natural numbers, yeah. So now I only need to search from 0 to 1,000 here. So let's look at this. So set of, should have done this before. Okay, and then once we find this unique set of three values, I just need to print the product, but that's easy to do. So, but the real part here is figuring out what the three values are here. So how would you approach this? Well, what's a brute force way to do this? Check every single possible one. So, and each one, they are related to each other, but let's just start by saying that A, B, and C are completely independent of each other. Okay? So, what's a brute force way? Well, what we can do is loop through every single possible choice of A, B, and C, right? So, how would you write this? Well, let's just consider A by itself. So A can be any number between 0 and 1,000, right? Depending on your definition of natural numbers, but 0 to 1,000 pretty much. So how would you write looping through each of those possible cases?
For a range of
Yeah.
0 to 1,000.
So yeah, for A in range, 0, 1,000. Yeah, let's just do 1,001 just because some people define natural numbers to not include 0. So you could, in principle, have 1,000 and 0 and 0, which would work, which actually wouldn't work, but I just don't want to...
Who are these people?
Who are these people? Very smart people.
On range, you said the stopping value is exclusive.
Yeah. So what I did there is just I made sure to hit 1,000. So then what do I do about the other two? So B and C. Just do 2 more for loops for B in range, 0, 1,001. For C in range, 0. Oh, that's 10,000. Yeah, I don't want to do that. And then what do I want to do now? I want to check if A, B, and C is a valid Pythagorean triple. So how do I check that?
If A squared plus B squared equals C squared.
So yeah, so if A power 2 plus B power 2 equals C power 2, then and since it's a unique one, I want to print A times B times C here, right? And we know how to do that. So print A times B times C. And we know, since it's a unique triple, I won't find any others. So what do I do now? Well, what's a way to just avoid looking anywhere else?
Return.
Or return or break. So a break, since I'm not in a function, I just do a break instead. All right, cool. So let's try this.
Are breaks considered kind of less taboo in Python than they are in some of the other languages?
Taboo.
Java and C++, they say you should avoid using breaks.
No, we should avoid using go-tos. Go-to is, for those who don't know, is just jump to a specific place in the code. So it's just less structured that way. But break is very well defined. It just means get out of the for loop that I'm currently in. Okay. Alrighty. So let's run this. Oh, okay. So they do mean non-zero. So I should print. I should print this, and this break actually only works for the first indented for loop, so it doesn't consider the other ones. So, and it'll be hard to be able to break out of every single one. Actually, what we can do is just do exit 0, but so we can do that, and so it printed 60, which. Oh, yeah, that was the point, yeah. That was the entire point, right? So, and A plus B plus C equals 1,000. Exactly. So, while we wait for this to run, how many iterations am I going to possibly be doing here?
N cubed.
Well, n cubed, right? So n is 1,000, so how many, so 1,000 cubed, what is that? That's a billion choices. It actually isn't that many, but I kind of want to avoid that as much as possible, right? So, and obviously this is going to run forever, pretty much. So it turns out we can actually make some optimizations here. We can, I'll show you how to eliminate actually 2 of the 3 for loops, but for now let's just remove 1. So we note that they're actually related by this equation, right? And they're also related by this equation, A plus B plus C is 1,000. So I actually don't need to loop through C now, right? So what can I do instead? Well, I know they must be related by this equation because I don't need to consider any other one. So I can just say set C to be 1,000 minus A minus B, because that's exactly what this equation says, right? And then now, if I just de-indent everything, and also now I don't need to do this check because I made sure that C was the valid number for which it works, right? But we also want to make sure that we fulfill these inequalities, so we just want to make sure C is at least B. Just a minor point, but so if C is at least B and this. Alrighty, and then, so basically we reduce this from 1 billion iterations down to 1 million, which is really nice. And it printed much faster now. If we didn't do that, we would have to wait 1,000 times longer to do this. Cool, so now we were able to do this. So, any questions about that? Okay. Do you guys want to take a break or just go all the way to 4:20 and I'll let you go early?
I have a question. How do you remove the other for loops?
Well, we're going to do that in a second.
Okay. I have one more question.
Yeah.
There's a power function in Python here,
Mhm.
where you can just instead of doing A star star, you just do power this
Mhm.
and this, right?
Yeah, it does pretty much the exact same thing. Cool. So removing the other for loops is actually really, it's not tricky, but it's really cool how it works. So to motivate that, how many of you heard, we've talked about HackerRank a few times. So on HackerRank, if you go to contests, and you go to, if you look at active contest, it turns out they have this Project Euler Plus contest. So what do you think the plus means? Oh, what?
Advanced.
In a sense, it's advanced. Okay? So if we solve problems 2 and 9, so what they do here for this competition is instead of saying 4 million, they say, they give you a number n and a number of test cases. So it's a more general version. Okay? So here, what they give you is, they give you t, which is the number of test cases. So like 4 million may be one of them, and 1,000 may be another. And they give you a bound on what n, the sum that you need to go to for to sum all the even numbers of the Fibonacci sequence. And so what you need to do is just, for each one of those, just print out the result on one line at a time. Okay? So as you can see here, we may have 10,000 test cases and a very large n, right? So if we try to do this here, so here they give you the integers t and n on through input instead of sys.argv, they do it through input. So just some boilerplate. What I usually do is I say t is the number of test cases, and so for every test in range of t, so this will just loop through the number of test cases. And since I get one integer for each of the test cases, I just need to read one integer at a time for each of the test cases. So I'm going to say in is int input. And then what I want to do is usually here is I make a separate method to solve on each of the n possible test cases. And I leave the boilerplate below. So I just call solve of n. And then I make a method solve n up here. All right. So what we can do is, you think, well, what we can do is copy the code that we just made, but what changes will I have to make to my code? Well, I'm instead of doing 4 million, I'm doing up to n instead. So what should I change about this? While it goes to n instead. So I'm going to copy and then paste it here. I hate it when it doesn't. Although it's really nice for like Sublime in here, if you select a piece of text and then just push tab, it tabs everything all. I really like that. So instead of here, I write n. All right. Hopefully this works. So what I do. So run code will just run a sample test case. It won't actually run the real test cases. So here it says, oh, you passed this sample test case. And it turns out that this program is completely correct, if I haven't made a typo. So what we'll see here is something surprising, hopefully. Surprise. Okay. Oh, so it didn't pass every test case. So it turns out that this algorithm is pretty efficient. But we saw from this list over here that the number of test cases could be huge and the n could be huge. So what optimizations could we make about our program? Where do you think the even valued terms are in the sequence? Well, 2 is obviously 1, right? One of them, right? Where's the next one? 3 over. Where's the next one? 3 over. It's every third term starting with the second element. So 2nd, 5th, 8th, 13th, etc. Why is that true? Well, if you have an even number term, and let's just suppose the one before it is odd, right? So odd and even. What's the sum of an odd and even number? Odd. So now the past number is even and odd. What's the sum of an even and odd number? Odd. So odd plus odd is even. So it's going to be an even number followed by 2 odd ones, even, 2 odds, even, 2 odds. it actually doesn't make a difference here because we were able to pass every test case. But if there are some problems where you will have to think of an optimization like that. You can't just brute force because the test cases are so big, which we'll actually see when we do the number 9 in a second, which will make us need to remove that other for loop. So we only have one for loop. So any questions about how we were able to solve that and how that optimization could be done? Yeah.
How would you make it go to the third term without having it loop through 2 more times?
Yeah, that's something that's actually there are some formulas which you could get the nth term quite easily, but you'll have to compute like some crazy exponential thing. But I'm not sure exactly how to do that, but just knowing how to find an optimization like that, that's what is important for solving these problems. Any other questions? Okay, so let's solve number 9. So it's funny, Project Euler on the actual site has over 500 problems, and they're only at 100 here, and some problems here only have like a 10% success rate. And let's actually look at number 9. Number 9 only has a 65% acceptance rate, which is actually pretty low. The reason for that is we'll see in a second. So let's have this. I want to copy my boilerplate down because it's the same for every problem. All right. Try again. Let's copy my boilerplate here. So now I just need to fill in the details for solve. Because for here you only get one integer for each test case also. So the numbers are around 3,000 for each of t and n. So what we solved here was solving up to 1,000. So let's just say that this was 1,000. So here we're given t, which is the number of test cases, and n is the number for which a plus b plus c is equal to n. So, and the thing is, we'll need to print the maximum of a, b, c, because before we had exactly one triple which had a times b times, which had a plus b plus c is equal to 1,000. But here, it could be any n, right? So what we'll need to do is we'll need to keep the track of the maximum product over all possible cases. So let's just copy our code down. So we can't do that exit 0 business again. So let's indent. So here now I need to keep track of a max product, right? So let's just say m is 0. And then I need to loop through n here instead of 1,000 because it's not 1,000 anymore. Yeah, so if c is at least b and we have the right product, if we have the right sum, then we better, instead of printing here, we may have a lot of products being printed. So now I want to have m be this product. But I may get a lower product in the future. So what do I want to do? I want to keep the max of what it currently is and this new product. So whatever it was before, it'll be the max of what it was and this new product. So max of m and this. Okay? So max can take an arbitrary number of arguments and just returns the max among all of them. All right? And then once we're done all that, we'll print m. And if I have not made a horrifying mistake, we'll... Oh, yeah, yeah. So if there's no such triplet, we'll need to print -1. So m should be -1 here. Yeah, thanks. So if we run that, it should work, hopefully. All right, cool. So let's see. So let's run our code. Hopefully, so what you should see that it won't pass every test case. So pass the first one. Second, third, What do you think that symbol is for the third test case? Took too long, yeah. If we hover over it, it terminated due to timeout. So on HackerRank, for pretty much every contest, you can set a timeout, and for Python, it's defaulted to 10 seconds. So if you can't solve your solution in 10 seconds, it says you'll fail the test case. So we actually failed 2 test cases now. Our program is correct, but it's just running too long. And why do you think that is? We have 2 for loops, exactly. So that's why that's such a low acceptance rate, because of the need to remove these for loops. And there is a little bit of math, but I think we can do it. Okay. Let's see. So what I'm going to do is I'm going to open a text document. So let's see. So we actually failed 5 out of 8 test cases, which is quite shocking. So let's see. Well, what are the equations we need to look at? Well, we have that a squared plus b squared equals c squared. That we need to have that true. And we're given this number n, so we have a plus b plus c is equal to n. Okay? How many, so we have 4 variables here, a, b, c, and n. So we're given n. How many of these are unknown? 3. How many equations do we have? 2. So if we try to solve this, we'll have 1 unknown left. That'll be the for loop. So that's how we'll do it. Cool. So the way we're going to do this is, let's just say that we solve for c here, in terms of the first equation. So if we solve for that, it's just doing the plus or minus square root of the other side. So plus minus square root of a squared plus b squared equals c squared. Equals c. Okay, so that's exactly the same thing. That's saying the same thing. So now we're going to do something that we have all done in algebra: substitute. So we're going to substitute for c in the second equation. So a plus b plus or minus square root a squared plus b squared equals n. So this will be kind of long, so I'm doing that. Who likes square roots? Anyone like square roots? I don't. So how do you get rid of square roots? Square it, right? But if I just square both sides, I'm going to have some square roots over here. So what do I do instead? Well, one thing I can do is just isolate the square root and move everything else over, right? So what I'm going to do is exactly that. So plus or minus square root a squared plus b squared equals n minus a minus b, right? Because I'm just subtracting a, subtract b. And now we can do a square. So the square of a square root is the stuff on the inside, obviously. So a squared plus b squared is on the left-hand side. So now if we think of this as n minus a minus b times n minus a minus b, this may be a long expression, but we can do it. So we have n times n, so that's n squared, minus n times a, so na, minus nb for this n and b. Then we go to the second one over here, so a and n, so we have another na. So now we have minus a times minus a, what is that? Plus a squared. Oh, that's nice. We have an a squared over here and an a squared over there. Cancels. Awesome. So let's see, let's carry on. Minus a times minus b, I hope that's plus ab. We have a minus bn, or nb, plus another ab, right? And b squared for the last one. Oh, we have a b squared on the other side. So let's see. So let's do some canceling. So we have a b squared over here and a b squared over here to cancel. Just subtract on both sides. So I'm just going to move this over here. And we have an a squared on the left-hand side and the right-hand side to also cancel. So now we reduced it to this. Okay? Any questions about how we got to here? Okay. So now we have three variables here, n, a, and b. I know n, so I have two unknowns. So what am I going to do? I'm just going to solve for one of them in terms of the other. So, and then the one that we, so let's just say that we solve for a here, so a equals stuff. Then that means that we're going to loop through b from 0 to whatever number n, and then just find the result for a, and then plug in the result for c. That's exactly what we're going to do. So let's just say that we're going to solve for a. Solve for a. So how do you solve for a variable and for a linear equation like this?
Get all the ones
Yeah, get all the terms that are multiplied by a on multiplied by a on the one side. Everything else that doesn't depend on a on the other side. That's exactly what we do. So
Why are you solving for a?
I can solve for a or b. It doesn't matter. It's just what I did, so it's just to be consistent. So n squared, I don't think it depends on a, so I'm going to move it over. Minus na, that definitely depends on a. Minus nb, that doesn't depend on a, so I'm going to add it to the right-hand side, so plus nb. Oh, we can actually make this better. So we have 2 na on the right-hand side, so I can make this even easier. And we have 2 nb, minus 2 nb, and also 2 ab's. So we can make this even smaller. So this will be a 2 nb over here, and a 2 na, and you bet that 2 ab depends on a. So how do I solve for a now?
Factor out the a.
Factor out the a. So negative n squared plus 2 nb. Yeah, equals a times minus 2n plus 2b. So how do I solve for a now? Divide. So negative n squared plus 2nb divide by negative 2n plus 2b equals a. Right, so now what I'm going to do is I'm going to loop through all possible values of b, plug in the result for a and c, and then do my calculation from there. So now I only have one for loop. And so we reduced it from n squared to n complexity. All right, so let's see. So let's refine our solution a little. So now I said that I'm gonna, Oh, I need to open in an editor, yeah. All right, so let's, I said that we're gonna loop over b. So let's get both of these side by side. So you can make this a little easier to look at by just multiplying by -1 and -1 on the top and bottom, just to make it look nicer. Minus 2, so n squared minus 2nb divided by 2n minus 2b. It's the same thing, but it just looks nicer. All right, so what I'm going to do is for b in range, so I need to start from 1 to n, but it actually won't work here. So the reason is that because of how the 2 works here, you only need to go to n over 2 here. So what we'll do is we'll just go to the integer version of n over 2. So it actually reduces the runtime here, but it actually is for correctness reason. All right, so what we'll do here is do our calculation. So n power 2 minus 2 times n times b divided by 2 times n minus 2 times b. And then c, well, I don't want to use this equation, right? Because Square root could be very expensive. But what's easier? I can just plug in here. So I know that c is n minus a minus b. So now I just plug that in, n minus a minus b. So there's actually a problem here. Well, it turns out that when you do a power, it turns it into a floating point number. So what I need to do here is just reduce it to an integer. But that's the only thing. So now I have b is an integer, a is an integer, so c is also an integer. So now I just need to check if a power 2 plus b power 2 equals c power 2. And, well, I can't have any zero solutions here. So I just want to make sure, since b can't possibly be 0 because I start at 1, but a and c might be. So I'm just going to say and a is at least 0 and c is at least 0. And then I do my m is equal to max of m, a times b times c. Okay? So anyone confused on how we were able to do that? To reduce from 2 for loops down to 1. All right. So let's do this. Hopefully, 2 equals, not 1. All right, cool. So now if we submit, hopefully this will work. I'm crossing my fingers on this.
Sorry, why is it from 1 to n over 2?
Because when you do it here, if we look back at our equation, when you do this 2 times n times b, if b is at least n over 2, then the top of this expression will be negative.
I see, that makes sense.
Yeah. It's just for correct. You actually, since the bottom will also be negative, it'll still work, but it's just to be absolutely correct, and also that I'm only looking through half of the solution, so my runtime is half, and we passed every test case. Awesome. So any questions on how we were able to do this? Any doubts about anything we were able to solve today? So what I'm thinking for the midterm and final is to have some kind of fun competition like this where you look at problems like these and to try to optimize problems like we were able to do, look at the math behind it, and try to see what could I make this problem do to pass these really long test cases. So I think something like this is pretty fun. So any questions about any of this? You can post a thread in the Google group. So, any other questions?
Can you scroll down?
Oh, yeah. So, it's just making use of 2 equations with 3 unknowns, and then just looping through one of the unknowns. And then, because we were able to solve for the other 2, based off those 2 equations.
Why a greater than 0 and c greater than 0?
Yeah, because there's no point in because the reason is that I don't want products that are 0, because if either I'm absolutely sure b will not be 0 because range starts at 1 and goes up, right? But a and c might be 0 in terms of b, right? Yeah. So what I want to make sure is that that will never happen. So I'm just avoiding a whole bunch of 0 checks here. Yeah. All right, so, yeah. Assignment 2 due date. So someone mentioned to me that Memorial Day is Monday, so I don't want you to be stressing about the assignment, so what I did is I postponed it by 1 day. So it'll be due Tuesday instead. I changed the due date on Blackboard, but I didn't change the PDF. I'll do that tonight. So yeah, assignment 2 is now due Tuesday, and I'll post assignment 3 sometime probably this weekend. Okay, it's mostly done, but there are just some things I need to fix. And also, assignment 1 solutions will go up pretty soon. Any other questions? All right, have a good weekend.